Hello there, Mr. Sutton here, bringing you the Algebra 2 Chapter 10 Quiz 2 Review Solutions on Trigonometric Ratios and Functions Part 2, dealing specifically with graphing trig functions and identities. For this first problem, we're trying to graph g of x equals 2 cosine 1/4 x. So for these graphing type problems, we're going to first identify the transformation of the original that's happening. Then we'll come up with the parent table. We'll do the transformations and we'll graph the points that we have. So for the transformations, the 2 outside the cosine function is giving us a vertical stretch. The 1/4 inside is giving us a horizontal stretch. It's a stretch because it's opposite of what you expect, and this is less than 1. So vertical stretch and a horizontal stretch. So now we need the parent table for cosine of x. So going from 0 to 2 pi, going by half pi's, we're going to have 0, 1, pi over 2, comma 0, pi, comma negative 1, 3 pi over 2, comma 0, and 2 pi, comma 1. And cosine has its own parent table different than this, so you might want to double check that if you're preparing for a quiz. So let's go ahead then and do our transformations. So we've got, let's see here, x has a horizontal stretch. So when I do the g of x table, I'm going to do not 1/4 x, but 4x for that. And then our vertical stretch, we're going to handle with a 2 times y. So we've got 4 times all the x values, so 0, and 4 times pi over 2 is going to be 2 pi. 4 times pi is 4 pi. 4 times 3 pi over 2, that's going to be 2 times 3 pi, which is 6 pi. And 4 times 2 pi is 8 pi. Now multiplying 2 by all these y values, we've got 2, 0, negative 2, 0, and 2. All right, putting that all together, I'm going to make my graph go from negative 2 pi to 10 pi. That'll let me get these x values in there. And then we can just go by 1s for the y-axis to handle these 2's here. So our first point, we've got 0, comma 2 right here. And then we have 2 pi, comma 0. 4 pi, comma negative 2, 6 pi, comma 0, and 8 pi, comma 2. And we just need to do one period of these trig graphs because they keep going on forever and ever with the same pattern. So here is our one piece of the cosine curve. For this problem, let's check out the transformations that are happening. So we have a negative 4 outside the function. The negative gives us a vertical reflection. The 4 gives us a vertical stretch. And then this minus pi over 2 inside the function is giving us a translation of right pi over 2. So vertical reflection and stretch and translation right pi over 2. All right, let's do our parent table for sine of x. So we've got from 0 to 2 pi, we've got 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. And now to incorporate these changes in the g of x function that we're using to actually graph this, for the x's, since we're going right by pi over 2, we have to do x plus pi over 2. And then for the y's, to get both the reflection and the stretch, we need to multiply negative 4 by the y values. All right, let's add pi over 2 to all the x values first. So 0 plus that just gives us pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, or just pi. And then pi plus pi over 2 is 3 pi over 2. 3 pi over 2 plus a pi over 2 is going to give us 2 pi, or 4 pi over 2. And this is 4 pi over 2 right here, plus another pi over 2 for 5 pi over 2. Now for the y values, multiplying by negative 4, we've got 0 is going to just still be 0. And then 1 becomes negative 4. Then we have 0, positive 4, and 0. So to get all this on a graph, I'm going to go by pi over 2's, starting at 0 and ending at 3 pi. That should help me get everything I need in the middle here for the x values. For the y values, I'm going to go from negative 6 to 6. That'll let me get these 4's in here. So our first point is pi over 2, comma 0. It's okay that that's not on the y-axis. Then we've got pi, negative 4, 3 pi over 2, 0, 2 pi, comma, positive 4, and 5 pi over 2, 0. And going through our dots here, this is our piece of the sine wave. To graph this function, 2 cotan of pi over 2x, let's look at the transformations first. So we've got the 2 out here giving us a vertical stretch. The pi over 2 in here, well, let me think here. Pi over 2, that's like 1.7 or something. That's bigger than 1. So that's going to be a horizontal shrink. All right, so vertical stretch, horizontal shrink. Let's write our parent table for cotan. So going from 0 to pi, we've got 0 and an asymptote there originally. Pi over 4 and 1. Pi over 2, 0. 3 pi over 2, negative 1. And pi with another asymptote, undefined kind of spot there. So to modify all this for the g function, the pi over 2 inside here means we have to multiply the x values by 2 over pi, the reciprocal of that. And then for the 2 outside the function, we're going to do 2y to incorporate that vertical stretch. So let's do the x values first. 2 pi over 0 is just 0, so that's nice. 2 pi times pi over 4. Pi's are going to cancel. We've got 2 over 4, which is 1/2. And next, 2 pi times pi over 2. Well, those are literally reciprocals, so that's just 1. 2 pi times 3 pi over 4. Pi's cancel again. We've got 6 over 4, which we'll do as 3/2. And then we've got 2 over pi times pi. Pi's cancel, so that's just 2. Now for the y's, multiplying these by 2. Undefined is still undefined. 1 becomes 2. Then we got 0. -2, and undefined. So to fit all this on my graph, I'm going to make my x values go by 1/2, and my y values can go by 1s. Let's graph all this now. So at 0, we have a vertical asymptote. That's what this undefined means. So I can just do a dashed line there if I want. I don't really need to, though, because the y-axis already gives us a guideline to approach. And then we have 1/2, comma 2 right here. 1, comma 0. 1.5 or 3/2, comma -2. And at 2 we have a vertical asymptote that we do need to draw. So I'm just going to approach the asymptotes and go through the points. So here is my cotan curve. Just one period. On this one, I'm trying to graph 4 secant of 2x. So for my transformations, the 4 out here gives me a vertical stretch. The 2 inside gives me a horizontal shrink. For the parent function, we've got going from negative pi over 2 to 3 pi over 2. We're undefined. Then we've got going by pi over 2 here, we've got 0, 1. Pi over 2 is another undefined asymptote. Pi, we've got -1, and 3 pi over 2, there's an asymptote. So for the g function, to incorporate these transformations, for the x's, we need to do 1 over 2 times x. Because again, it's a shrink. It's opposite of what you think it is. And then for the stretch out here, we're going to do 4y. All right, let's multiply 1/2 by all the x values. 1/2 times negative pi over 2 will be negative pi over 4. And then 0 is still 0. Pi over 2 becomes pi over 4. Pi becomes pi over 2. And 3 pi over 2 becomes 3 pi over 4. So that wasn't too bad. Let me do 4 times my y values. All the undefineds are still undefined. So we've got undefined, 4, undefined, -4, and undefined. So I'm going to make my x values go by, it looks like pi over 4 is a good interval to capture all those. And then the y values can still go by 1s if I'm going from negative to positive 6. All right, so graphing this out, we have negative pi over 4 right here, and that's an undefined asymptote, so let me just draw that in. Next, we got 0, 4, asymptote at pi over 4. Pi over 2, comma, -4 is down here, and then another asymptote at 3 pi over 4. So approaching the asymptotes and going through that one point, and you kind of have to know what this looks like beforehand. So we've got kind of teeth. Here's one tooth up here and another tooth down here. On this problem, we have 2 people swinging jump ropes. The highest and lowest points of the middle of each rope are 80 inches and 2 inches. Each rope makes 2 revolutions per second. They want a model for the height in inches, so that's h, of one of the ropes as a function of time, t, which is in seconds, given that the rope is at its highest point when time equals 0. All right, so to write this is going to be a trigonometric model because the height of the rope just keeps cycling between 2 and 80 as the rope goes round and round. So I know that I'm going to need a few things. I need my amplitude, my A value, my B value. I also need an H and a K. So let's get each of those. For the A value, the amplitude, I need half the height. That's the amount of fluctuation. So that's going to be 80 minus 2 to get the height, and then divide that by 2. 78 over 2 is 39. And then for the B value, before I can get that, I need the period. And they didn't give me the period. They didn't tell me how long it takes the jump rope to do a full cycle. They gave me the frequency instead. They said it was 2 revolutions per second. So if I take the reciprocal of that, I figure out how long it takes to do 1 revolution. So if our frequency is 2, our period then is going to be 1 over 2. And to get the B value, the horizontal stretch factor from the period, we have to do 2 pi divided by the period. So 2 pi divided by 1/2. Same change flip, that's really 2 pi times 2 over 1, which is 4 pi. So that's our B value that makes it into our formula. I'm going to do the K value next. So that is the midline. The vertical shift, that's going to be the average of the highest and lowest points. So 80 plus 2 over 2. 82 over 2 gives us 41. And now for the H value, so that's going to be where the cycle starts for the trig function that we're choosing. Now the easiest way to do this problem, since they told us the rope is at its highest point at time 0, they're basically saying we're at the top of the wave on the y-axis, or I guess this would be the h-axis. So cosine likes to start at the top of the wave at x equals 0. So if we use an h value of 0, we can use the cosine function, the positive cosine function. So for positive cosine, we can use h equals 0. Okay, now just a few other kind of ways of thinking about this. If we had different points that the jump rope was at, just to get you a full review, if we were at the lowest point at time 0, then you'd want negative cosine because that starts at the bottom of the wave. And if you were at, the rope was at its like middle point going up, that would be positive sine. Middle point going down would be negative sine, all at time 0. In any case, our formula we're going to use, we're going to do A positive cosine B x minus h plus k, and we'll use h and t instead of y and x, but same idea. So we can write h of t equals the a value 39. We've got cosine and the b value of 4 pi. H is 0, so we just have t minus 0, or just t, plus our k value we found of 41. So this all together, 39 cosine 4 pi t plus 41, that is our h function. On this problem, they want us to simplify this, which means that we want a single number or trig expression, and we don't want any reciprocals, and we don't want any weird funny business inside the trig function like this negative x here. So there's a few things we can do here, a few identities we can use to help us out. So first thing I always try to figure out is if there's weird angles, and this is part of my APAC, AP, AC sort of toolbox. So we have angle identities that we try first, then Pythagoreans if you have squared trig functions. A stands for algebra if you need to factor or FOIL or anything or multiply things out. Also splitting up fractions. And finally the C is just turning everything into cosine and sine, which usually will get you there eventually, but it is the longest thing. Now one thing that we have to do first on this problem, since we have a negative angle, we're going to use our negative angle identity. There's 6 of them depending on your trig function. The relevant one here is that secant of negative x equals secant of x. And it's related to the cosine of negative x equaling just cosine of x. It's an even function. So we can rewrite this as just secant of positive x. Now for the squared trig functions down here, we can do something with those as well. There's a Pythagorean identity. It's one of the big three. So this one is cotan squared plus 1 equals cosecant squared. There's also, you might recall, tan squared plus 1 equals secant squared, and sine squared plus cosine squared equals 1. So they're all useful in different situations. Make sure you've got all those memorized or written down. So in this case, to match this negative cotan squared plus cosecant squared pattern, in this identity I could just subtract cotan squared over to the other side. And that would give me basically all this. And then I'd have 1 left over on the left side. So all of this stuff then is just equivalent to this 1 that would be left over. So I can replace this whole thing with 1, and then just simplifying that fully, we have secant of x.